Find the asymptote and standard equation of hyperbola whose center is at the point of origin. So let A is less than C but greater than 0. So meaning to say that the value of C is greater than A. And B is equal to the square root of C squared minus A squared, an equation of hyperbola whose center is at the origin with the following condition. So the first condition, foci at F1, the coordinate of negative C0, and F2, the coordinate of C0. And the vertices at the coordinate of negative A0 and positive A0 is x squared over A squared minus y squared over B squared is equal to 1. So this first condition, this hyperbola is a horizontal hyperbola. Okay, so we have here the second condition. If the foci at F1, the coordinate of 0, negative C, and F2, coordinate of 0, positive C, and the vertices at V1, coordinate of 0, negative A, and V2, the coordinate of 0, positive A, is y squared over A squared minus x squared over B squared is equal to 1. The second condition of hyperbola is a vertical hyperbola. Okay, so we have here the figure of the vertical and the horizontal. So the first figure, where the parabola is open to the left and right side, so this hyperbola is a horizontal hyperbola, where the equation is x squared over A squared minus y squared over B squared is equal to 1. And the second figure, where the graph of hyperbola is open up and down, this hyperbola is a vertical hyperbola. Okay, where the equation is y squared over A squared minus x squared over B squared is equal to 1. Example, find the asymptote and equation of the hyperbola centered at the origin with foci at the coordinate of plus minus 70 and vertices at plus minus 50. So if you look at the given, since the center is at the point of origin and the foci has the coordinate of negative 70 and positive 70. So the value of x is changing while the value of y still remain as 0. So it means that this hyperbola is a horizontal. So we will use the horizontal formula. Okay, so before using the horizontal formula of a hyperbola, we will solve first, or we are going to identify first the value of C. Remember that C is from the center to the foci, or from the center to the focus. Okay, since the foci or the focus is 70, so therefore the value of C is equal to 7. Then the value of A. So remember that the value of A is from the center to the vertices. And since the given here is center is 0, 0, so from the center to the vertices is 5. So the value of A is equal to 5. Since you have already the value of C, which is 7, and also the value of A, which is 5, you are going to solve the value of B using the formula of B is equal to the square root of C squared minus A squared. Remember, if it is a hyperbola, the value of C is greater than the value of A. Okay? Since the value of C is 7 and the value of A is equal to 5, we are going to substitute. It becomes 7 squared, the square root of 7 squared minus 5 squared. Okay, so when we are going to simplify, the result is square root of 49 minus 25. And square root of 29 minus 25 is equal to 24. Okay, then we are going to find the factor of 24, which is a perfect square. So the factor of 24, which is a perfect square, is 4 times 6. So the value now is equal to 2, the square root of 6. Remember that 6 is not a perfect square, so it will remain as a radicand, or the radicand inside the radical sign. So the value of b is equal to 2, the square root of 6. Then after that, you are going to solve the equation of hyperbola using the horizontal equation. Okay, which is x squared over a squared minus y squared over b squared is equal to 1. You are going to substitute the value of a and the value of b. It is just for you to easy to substitute, or you'll use b is equal to the square root of 24. Okay, so substitute, it becomes um, x squared over 5 squared, since the value of a is equal to 5, minus y squared over the value of b, which is the square root of 24. You can cancel the radicand, the radical and the exponent. So the square root sign and the exponent, which is 2, so you can cancel. So the remaining value is only 24 for the denominator of y squared. So the equation of hyperbola is equal to x squared over 25 minus y squared over 24 is equal to 1. Next is you are going to solve the asymptote. To solve the asymptote, we are given the formula, which is y is equal to plus minus bx over a. The first asymptote is the positive asymptote, and the second asymptote is the negative asymptote. Okay? Since you are given, or the value of b is 2 square root of 6, so it becomes 2x square root of 6 over the value of a, which is 5. And the second asymptote, we have y is equal to negative 2x, the square root of 6 over 5. Okay, so another example, find the asymptote and the equation of the hyperbola whose centered at the origin with the foci at the coordinate of 0 plus minus 5 and vertices at the coordinate of 0 plus minus 3. So if you look at the given, the value of y is changing. So it means that this hyperbola is a vertical hyperbola. So we will use the formula of vertical. Okay, so first thing to do is we are going to identify the value of A and the value of C. Since foci is given and also the center, remember that the value of C is from the center to the foci, or from the center to the focus. So the value of C is equal to 5. Remember that the coordinate of foci is 0 plus minus C. So the value of C is equal to 5. Okay, for the value of A, remember that the vertices, the coordinate is 0 plus minus A, so therefore A is equal to 3. Okay, since you have already the value of A and also the value of C, you need to solve the value of B, since it is useful for our equation of hyperbola. Okay, so solving for the value of b, we have b is equal to the square root of c squared minus a squared. Remember that c is 5 and a is 3. When you are going to substitute, it becomes the square root of 5 squared minus 3 squared. When you are going to simplify, the result is the square root of 25 minus 9. And subtract 25 minus 9, the result is 16. And when you are going to extract the square root of 16, the result is plus minus 4. Okay, so since you have already the value of b, which is 4, and the value of a is 3, so you can solve now the standard equation of hyperbola using the formula of a vertical hyperbola, which is y squared over a squared, minus x squared over b squared is equal to 1. You are going to substitute the value of a and the value of b. We have here y squared over the quantity of 5 squared minus x squared over the quantity of 4 squared is equal to 1. When you are going to simplify, it becomes y squared over 25 minus x squared over 16 is equal to 1. So that is your equation of the standard equation of hyperbola. Okay, next is you are going to solve the asymptote. Okay, to solve the asymptote using the formula of y is equal to plus minus bx over a. Since you have the value of b, which is 4, and the value of a, which is 3, so you are going to substitute. It becomes y is equal to 4x over 3, and y is equal to negative 4x over 3. Okay, so that is the equation of the asymptote. Okay, thank you for listening, and do not forget to subscribe my channel.